floating over the fields outside San Antonio. I'm going to guess that's a sorghum field. Thanks to Greg for that clip, and we'll look at more of that at the end of the program. Let's take a look at the surface map. We've got another invasion of cold air coming straight in from central Canada. Temperatures down into the 30s in Minnesota with snow. Further out in the southeastern U.S., we've got the tropical air flowing north from the Gulf of Mexico. This looks to be like some cold air damming. The fog is kind of a giveaway there. You can see 70 over 67, rather cool conditions, and that's because the cold air is bound up right there in the Carolinas and Virginia. That's left over from the previous outbreak of cold air, probably over the past couple of days, and it's unable to cross the Appalachians there, so it just kind of gets stuck there. And the warm front just to the south. And with that nose of tropical air coming north, we've got thunderstorms in Alabama and Mississippi, and we'll take a closer look at that in a minute. Also in Florida, more thunderstorms. It is a dry front through Louisiana and Texas, and some welcome cooling with temperatures down into the 50s and 60s. And this appears to be a separate chunk of cold air coming in from the Pacific. This one is from Canada. This one is from the North Pacific and probably British Columbia. And speaking of British Columbia, let's take a look out in the Pacific and see what's going on in that region. Another weather system off the coast of the northwest U.S. and heading up into Alaska, there is some very cold air, minus 20 just north of Nome, minus 17, and Nome itself is down to 0. That's that chunk of cold air reflected in the thickness field. However, most of that cold air is coming down into the Bering Sea. You can see 14 there. That's pretty cold for that part of the Pacific. And we've got some snow coming down a little bit off the diagram right there. Yeah, 29 at whatever station that is. And then out in Canada, it is warmer, 16. And several days ago, we had minus 20. So that's a definite warm-up. And we've got near freezing conditions starting to show up with that deep fetch of southerly flow. And Yellowknife itself, 25. The Atlantic is quiet this afternoon. One occluded low off of Newfoundland. Some cold air coming in its wake. Kind of a mix of rain and snow. But as you go further south, Quebec has warmed up, starting to see some 40s, and Maine up into the 50s. So, yeah, it's starting to look like April. Another way that we know it's April is when things get busy at the Storm Prediction Center. Enhanced risk across much of Georgia, eastern Alabama, and the southern Appalachians. Severe thunderstorm watch is up for Alabama and a tornado watch for Georgia. Let's take a closer look at that. We'll just start out with a convective outlook. This is kind of useful. Not only do you see the aerial extent of the threat area, but you can overlay these tornado outline regions, and we can see the enhanced 10% region across central Georgia. So that'll be a focus for this afternoon. And it kind of arcs up with that warm front that we showed earlier. North of the warm front, you always have backed flow. Winds out of the east, northeast, southeast, kind of an easterly component there. And that will stretch out your hodograph and make it favorable for supercells. Pretty substantial wind risk coverage and hail at a modest 15%. A sneak peek for tomorrow shows that the risk area moves out into the eastern Carolinas and central Florida. And then for Friday, it's probably going to be a fairly quiet forecast lab program. When we start analyzing these severe weather areas, I think it's important to look at the satellite imagery because it's very intuitive. It's pretty similar to what you would see if you stepped outside. For example, anvils coming off those storms in Florida, and we can see them here and there across Georgia and Alabama. One thing I'm seeing is that these don't appear to correspond to any definite boundaries. There may be a little boundary through here that could be near where that warm front is. The ones to the south, yeah, they're kind of lined up, but I don't really see any definite surface boundary. Maybe this one here. That appears to be a gravity wave. You can see back behind it these transverse bands. If we take a look at the surface map, that's probably going to correspond to a slight wind shift right there. I don't see much of an air mass contrast, mostly just a change in the wind and maybe some very slight drying to the west. So extending that up into Alabama, this kind of all looks like the same air mass. Maybe the low-level jet a little bit stronger out to the east. And what we're looking for, again, is boundaries. Now we can see that the air mass is somewhat distorted by outflow. This appears to be convective outflow right there. And then the unchanged, raw, tropical air is still flowing north like that. So we go from 90 in southern Alabama. That's probably going to be very unstable conditions, 90 over 70. And as we go north, 81 over 72, and it's somewhere around here that we appear to hit a boundary. We can get some help from SPC. And we'll go to this mesoanalysis graphics, go into the southeastern U.S., and look at some of those kinematic fields, such as velocity tensor magnitude. Well, I don't see anything definite right there. You can certainly pick out the front. That shows up very well. But the little boundaries where those storms are firing, they don't really show up that well. Let's go to the convergence. And there again, all we see is kind of a vague convergence axis right through there. And the shading, the green shading, indicating some weak cyclonic flow associated with that. So that's acting very much like a trough, maybe a very slight convergent boundary. So on a day like this, you're going to be working mostly with a nowcasting process, looking at where the storms are and using that to forecast where they're going to be over the next few hours. And in the environment, a good place to start there is going to be your dew points and wind barbs. Lots of moisture. You can see all the purple there, indicating widespread 70s dew points all the way up into southern Georgia. And those convergent lines, they don't really show all that well. The main front right there, that's delineating a transition from very dry air to very moist air. And the short-term radar composite, that'll give us some idea of the storm modes and how discrete that they'll be. I find this product very useful for that. So we can see that later in the afternoon we transition into a couple of discrete cells. This doesn't look all that linear. It's kind of along a common axis for sure, but I do see some discreteness indicated by the high-resolution rapid refresh. I think the models probably excel relative to what we can do with soundings and that kind of thing, so I tend to use this product to find what kind of storm modes we're looking at later in the day. And I can supplement that with the soundings, and I go to a relatively unaffected part of the air mass, and I can see that there's significant 0 through 1 kilometer shear, storm movement well off that hodograph. In other words, the SRH is being swept out through a very large area, and that'll bring those values well up to 200 and 300, which means definite tornado potential. As far as instability, that looks like some moderate instability right there. Not dry adiabatic, but certainly steep enough to give us capes of 2,000. And the Significant tornado parameter up there at 3.5. That's pretty high. So that indicates very good possibility for EF3 tornadoes if we do get discrete cells. And another thing that I might look at is the D-Cape up there at about 900, which means since it's kind of elevated, there could be a chance that storms will transition into linear modes or HP modes. Of course, the actual wind shear up at the anvil levels is important. Not a whole lot of that, so I think we are kind of favoring classic supercell modes until things start lining out. And that'll probably happen later this evening. And you can see that take place 10 or 11 p.m. Get some large clusters of storms. Then things start fizzling towards dawn. And one thing I forgot to point out is the lack of capping. And that means numerous cells. That can really increase cell competition and make it hard for any one cell to become severe. Now, typically, as we get into evening, we end up with a couple of key cells that become the dominant ones as the weaker ones die off, the weaker ones being like this stuff right here. So we're not going to be out of the woods until later this evening. So a couple of areas we're looking at, one out there in Georgia and then the southern region in Alabama. So we've already got a tornado warning for central Georgia there, east central Sumter and western Crisp County. This will probably change by the time you're looking at it on YouTube. But the storms, yeah, this one does have a little bit of a curved shape to it, which is indicative of rotation. There's another one right there. And yeah, these up here, they show a little bit of curvature there. And of course, the real litmus test is the velocity fields. That's the base velocity. We need to subtract out the storm motion. I think a good one to work with is going to be 220 at 30. That'll change as the day goes on. And that'll give us a more realistic look at that velocity. And there you can see that couplet. The radar is pretty far to the west for this example, but you can see the strong outbounds and somewhat weaker inbounds. And those are magnitudes of about minus 15 inbound and 40 outbound. So that's about 50 knots a shear across a broad area. And this is up at 13,000 feet, so this is not really ideal. You probably want to be using that radar. However, it is useful for the stuff out there in central Alabama. Not much going on with that, but likely we'll see things continue to organize. Of course, not all of our viewers are in Georgia. Many of you are across the U.S. and Canada, so let's take a look at weather in your area. We still have a progressive pattern, somewhat zonal, west to east, divided up into these medium-scale troughs and ridges. I would say probably one long wave off the west coast, maybe another one out here. Can't really see at this scale here, but let's check out what happens over the next few days. There's that troughing that's affecting the southeastern U.S. Got the cold air advection building in this trough into the central U.S., and likewise warm air advection helping to build this ridge on the west coast. Going into the remainder of the week, we see amplification of the pattern, building up that ridge into the Canadian prairies and building the troughing into the eastern U.S. So that'll continue to bring some cool air into the central and Midwest regions. And then we're going to see this jet moving on to the northwest coast. That's going to bring some deteriorating weather for that region. And then we start building this troughing in the western U.S. Let's see how that evolves into next week. That's going to be about the 12th and 13th. Yeah, it looks stormy for California. And probably cyclogenesis in the southern Rockies, maybe the Central Plains. So probably storm chances are going to come up across much of the central and southern U.S. later next week. And then just a quick run through of the GFS surface field. I'm using 925 millibars just off the surface to look at moisture. Now typically in winter I'm looking at maybe these panels here, the precipitation and sea level pressure. But in April, I don't really like that so much. Really that moisture is the key to what's happening, and we need to track how that evolves. So for example, let's bring that up to the current run, 925 millibars. You can see the dry air coming back in behind that front. Now moisture, absolute moisture such as dew point mixing ratio, that makes a really good tracer for air mass source. So this almost certainly came from Canada because it's very dry. It could come from the mid and upper levels also. And likewise, this obviously came from the Gulf of Mexico. So let's go forward and see how things evolve. The cold air, dry air sweeps across much of the eastern U.S. for a good 3 or 4 days. Finally, by Saturday and Sunday, we're bringing the moisture up into Texas, the return of 60s dew points, and that interacts with that next frontal system on Sunday. So probably storm chances coming up as soon as late in the weekend. And continued interaction through Monday and Tuesday. So I'd expect more thunderstorms across the central U.S., Texas, Oklahoma as well. And finally, it looks like, yeah, that's going to be a cyclone right there. That's going to be the 12th and 13th. That corresponds to that deep troughing that we saw on the upper level chart. Let me go back further, go back to the 12th. Yeah, see that strong cyclogenesis there in Colorado, bringing that low-level jet up to the north. Looks like a frontal boundary right in here. So probably some very good severe weather chances for Tuesday and Wednesday. By Wednesday, it does look like that cyclone moves up the boundary into Iowa. That'll bring veering flow to Oklahoma and Kansas and heightened severe weather chances for Iowa, Minnesota, Wisconsin, and Illinois. Maybe some severe weather chances going up for Wednesday night as that low-level jet builds back in. And after that, we'll just have to see. Saturday and Sunday, this 15th and 16th, or I should say 16th and 17th, that's quite a ways off. But looks like more cold air is in store and more thunderstorms as well. So one last look at the situation before we render and upload the video. Still a little bit disorganized, but we do know that the potential for severe weather is in place across much of the southeastern U.S., and we've still got that tornado warning for parts of Georgia, another one further to the south. So check it out this evening and keep tabs on what's happening. Big Rig Steve is not reporting this afternoon. He's in Memphis. I think he's loading up. So we'll be back to him on Friday. We'll leave you once again with some footage over the fields of San Antonio, and we'll be back once again on Friday. We'll see you then. Bye-bye.